When starting a new course on Autodesk Inventor, I find it very helpful to step back and provide everyone with an overview of what Autodesk Inventor does and go over a few of the basic workflow steps so everyone has a good understanding of why we're here and where we're going. During this course, we will be working with a small engine that you might find in an RC boat, but to cover the basic workflow concepts, I like to fall back to the toys that allow me to do the things I do today, the trusty Lego. The reason for this is nearly everyone on the planet will recognize what they are and how they work without too much explanation, and it allows me to easily explain the concepts. I see Legos as one of the most basic physical prototyping tools around. You have a bucket of standard parts, and you snap them together in different configurations to build anything you could dream of. Autodesk Inventor is a digital prototyping tool that allows you to build parts like a single Lego brick or parts of an engine, and then put them together and test how they would function before you actually manufacture any real parts. But in Autodesk Inventor, rather than starting with a bunch of predefined bricks that you might pull out of a bucket stored in the closet, you're actually pulling parts that you've built from a folder on your hard drive. The workflow in Inventor can be broken down into 3 major steps: building parts, assembling parts, and documenting your designs with drawings. When building parts, you'll sketch 2D shapes and use modeling operations to add and remove material to sculpt a part. I've captured a few images to help show how you might build a simple Lego brick in Inventor so that you can better understand the process. Once you've built the parts needed for your design, you can begin pulling them into an assembly file and connecting them, in this case, to build a simple Lego house. Once you understand the software, you'll be able to build much more complex parts and assemble those to build something more advanced. Last, but certainly not least, you must be able to document your designs so that when the time comes, you can have those parts manufactured. This will be done by creating views of your parts and assemblies that will be used to completely define how the parts should be manufactured. The beauty of the entire system is that all the parts, assemblies, and drawings are connected, so if changes are made to any part, the assemblies that contain the part and the drawings all update instantly, so you can focus on improving your designs rather than wasting time redrawing 2D views of your parts.